Okay, I have these exposed. We're going to go through this last problem. Another proof here. We're told that JK is perpendicular to JM, KL is perpendicular to ML, angle J is congruent to angle M, and angle K is congruent to angle L. So the first things obviously we would do is state in statement number 1 the statements that were given as true and write the reason given. And at the very end, we would be listing our last statement that we want to prove. We want to prove that JM is perpendicular to ML and JK is perpendicular to KL. So when we start seeing all of these letters here and looking at this figure, if we're talking about JK perpendicular to JM, I notice that both of these line segments have a point J in common. So we're talking about that angle formed at J. Since the lines are perpendicular, that means that they form a right angle. That's the definition of perpendicular lines. So we can put that angle J must be a right angle, and also angle L, where KL and ML intersect, is also a right angle. Then we also can say, well, if they're a right angle, then they also have to be 90 degrees in measure, because that's the definition of a right angle. So first we prove that they're a right angle, because that's the perpendicular lines, and then we prove that a right angle is 90 degrees, because that's the definition of 90 degrees. We can't just say, oh, because they're perpendicular, they make 90-degree angles. We have to say they make right angles, which are 90 degrees. They also told us that J is congruent to M and K is congruent to L. So that means if they're congruent, then the measure of angle J is equal to the measure of angle L, and the measure of angle L is equal to the measure of angle K. We're missing a step over here, it just isn't filled in.